covalent bonding and shapes of molecules. Okay, so first we've got the definition for covalent bonding. So covalent bonding is the strong, it's important to have that word, strong electrostatic attraction between a shared pair of electrons, that's an important word, between a shared pair of electrons and the nuclei of the bonded atoms. So that's the definition of covalent bond. It's a strong electrostatic attraction between a shared pair of electrons and the nuclei of the bonded atoms. So we'll just take a very simple example. If we take a hydrogen atom, and a hydrogen atom is just an s orbital. Okay, that's an atomic, it's called an atomic orbital. Atomic orbital. So we take a hydrogen atom and another hydrogen atom, the two s orbitals, and when they overlap to make a hydrogen molecule, those two atomic orbitals overlap to make a molecular orbital. And that's all that is happening. So the two atomic orbitals overlapping and sharing a pair of electrons. Okay, now this type of bond is called a localized bond. That's because the attraction is just between that pair of electrons and the nuclei of the two hydrogen atoms. So it's called a localized bond. Okay, whereas in an ionic structure, if you take an ion like sodium ion, the attraction is in all different directions. And it is not localized because it can attract, the sodium ion can attract in all different directions. This is a giant lattice structure. Whereas for something simple like hydrogen, it is a localized bond because of the attraction of the electrons between the two nuclei. Okay, you need to be able to draw dot and cross diagrams, just like for ionic bonds, draw dot and cross diagrams. Okay, so let's just do a few examples. So let's take CH4. Okay, how can you recognize if a molecule of a compound has got covalent bonding? You recognize it because it's between two nonmetals. A covalent bond is always between two nonmetals. Now, you look at carbon. Now, there's two ways to draw this. You can draw it the circle method. There's another way I'm going to show you. You put the symbol of the atom in the middle. Remember, we're only interested in the outer electrons. Carbon is in group 4, so carbon has got 4 outer electrons, and we've got 4 hydrogens overlapping. 4 hydrogens overlapping. It's a shared pair of electrons. You put the symbol in the middle. Hydrogen is in group 1, so hydrogen I'm going to call dots. Doesn't matter if you call it dots or crosses as long as they're different. So 1 electron, because hydrogen is in group 1, carbon's in group 4, so 1, 2, 3, 4. And that's the dot and cross diagram for methane. For CH4, it's called methane. Okay, another way, you don't have to do the circles if you don't want to. You could just simply go C, H, H. You've got to be careful when you're drawing this though. C, H, H. And then you put a dot cross, dot cross, dot cross, and dot cross like that. So that's another way to represent it. But you're only showing the outer electrons. And then when you draw these covalent bonds, you might be asked to draw the displayed formula, which means you draw all the bonds out. This is called the displayed formula, which is when you draw all the bonds out. And that's the displayed formula for methane, and you've got the 4 covalent bonds. Okay, let's try another example. This is a simple example. Let's go a bit harder. So if we take something like water, and you draw the dot and cross diagram for water. Okay, so again, we know it's an oxygen, and there are 1 hydrogen and 2 hydrogens overlapping. Hydrogen has got 1 outer electron, so put 1 outer electron in the shared part. Oxygen is in group 6, which means that it's got 6 outer electrons. So we go 1 there, 1 there. Oxygen is crosses, and then we've got cross together, cross together. Okay. Now, so these are called bonding pairs of electrons because they're bonding. These here, these 2 here are called lone pair of electrons because they are not bonded. Okay, you can also call them, actually, you could call them non-bonding pairs as well. Okay, because they're called lone pairs. So water has got 2 bond pairs, and we're going to go BP for bond pairs, and water has got 2 lone pairs, LP. And that's the bonding, the dot and cross diagram for water. Okay. There's a few other examples. So let's take BF3, boron trifluoride. Okay. So again, get your shape. You got your B, and you get your 3 Fs. My writing is not very neat. Okay, fluorine is in group 7, and you have to draw all the 7 electrons. You can't miss them out. 2, 4, 6, and then 1 in the shared pair. And you have to do that for each one, otherwise you won't get the mark. 7 electrons, 7 electrons. Doesn't matter whether you use dots or crosses, as long as they're different. The dots are for one and crosses for the other. And then boron is in group 3, which means that it's got 3 outer electrons. Remember, only we're bothered about the outer electrons. Okay, so I'm going to put 1 here, 1 there, 1 there. So what do you notice about BF3? BF3 does not have, the central atom does not have full shell. It only has 6 electrons in the central atom, but that's okay. It's got an empty orbital, and that empty orbital could be used for something. It's okay to have an empty orbital. There's an empty orbital on the central boron atom. Okay, which is okay. All right, let's try another one. Let's try SF6. Okay, now this is sulfur. This is going to be difficult to draw with 6 fluorines. Okay, 1, 2, 3, 4. I'm going to fit them all in. 5, 6. F for the symbol in the middle. Okay, now I've not got time to do it, but you have to draw all the fluorine, the 7 electrons. But I'm just going to do one, but you need to do it for every single one, okay? Sulfur is in group 6, so has 6 outer electrons. 1, 2, 3, 4, 5, 6. And the dots. And fluorine, you need to draw the fluorine electrons, but I'm just doing it quickly. So what do we notice about sulfur? The central atom, sulfur. Okay, so it's called the central, because it's in the middle. Central atom sulfur. Sulfur has got 2, 4, 6, 8, 10, 12 electrons. Well, that's okay, because sulfur is in period 3. Sulfur, the maximum electrons you can have in the third shell is 18 electrons. So it's okay that sulfur has got more than 8 electrons, because the third shell, because sulfur's in the third period, can hold up to 18 electrons. Okay, right, let's do a couple of trickier examples before we move on. So the slightly trickier examples are the carbon-carbon double bonds. All right, classic example is CO2. Okay, so you've got carbon, and then you've got oxygen, and you've got another oxygen. Okay, oxygen, CO2. Now this is a double bond, carbon-oxygen double bond. So carbon has got 4 electrons. Okay, when you represent a double bond, you go dot cross, okay, because it's the dot is from carbon, the cross is from oxygen. Dot cross, and then let's just finish this off. Oxygen's got 6 electrons, so we need 4 more electrons for oxygen, 4 more electrons for oxygen. Okay, now when you're representing a double bond, you cannot go dot dot cross cross. Okay, it's got to show, you can't do that, it's got to show that 1 electrons come from one atom and 1 electrons come from the other atom, and 1 electrons come from one atom and 1 from the other. Okay, and if you want to do this without using the circles, what you can do, you've got to make it very clear though, so don't do it too small. You go dot cross between the carbon and the oxygen, dot cross, and then the other for oxygen. So you can represent it like that if you want to. Another common example is nitrogen. Let's have a go at nitrogen then. So nitrogen is N2. Now nitrogen is actually a triple bond between the 2 ends. All right, so we've got the, make sure, don't do this too small, make sure you've got plenty of room. The 2 nitrogen atoms overlapping. So this is going to be a dot cross, because it's a triple bond. Nitrogen has 5 electrons because it's in group 5. So 3 dots, we need 2 more dots. 3 crosses, we need 2 more crosses. Okay, finally, let's give you one more example. Hydrogen cyanide. Okay, so hydrogen cyanide looks like that. Again, it's a triple bond. So let's draw carbon is the central atom, then you've got nitrogen, and then you've got hydrogen, HCN. Okay, so let's do the triple bond first. So dot cross, I've not left enough room, dot cross, triple bond. Nitrogen's got 2 electrons left over. Okay, carbon is dots, 1, 2, 3 dots, carbon's got another dot, and then hydrogen's got a dot as well. And that's dot and cross diagrams. Okay, for one final example, which is a bit unusual, that's called covalent bonds. There's another type of bond called a dative covalent bond. Alright, it's a dative covalent bond. So a dative covalent bond. It can also be called a coordinate bond. It's got another name, coordinate bond. Okay, so this is still a shared pair of electrons, but this is still a shared pair of electrons, but both electrons have come from the same atom. Both electrons have come from the same atom. Okay, so the classic example of this is if we've already drawn BF3. Okay, so let's just draw BF3 again because we've done it once already. Boron trifluoride. Right, so remember boron's got 3 electrons of its own and fluorine's got 7. And you've got to do it on each example. 7 electrons of its own. Okay, boron trifluoride. Now remember we said that that has an empty orbital. Okay, now if we take, that's BF3. Now if we take ammonia, NH3, the dot and cross diagram for ammonia, N, H, 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 hydrogen's got 1 electron. Okay, nitrogen's group 5, nitrogen's got 5 electrons, 3, 4, 5. Nitrogen has got a lone pair of electrons. So what nitrogen can do, it can donate, it can share this lone pair of electrons, and that is called a dative covalent bond, because boron has an empty orbital, nitrogen's got a spare pair of electrons, and they can share, and that is a dative covalent bond. Now when you draw it, I'm not going to draw all of it because it'll take too long, but you just show it as an overlapping the B and the M, and it's, instead of dot cross, it's cross cross, or it can be dot dot, but you've got to have the same electrons to show that they've come from the same atom, and that is called a dative covalent bond. And how you would represent it in displayed formula is you would go BN, and N, don't forget N's got its 3 hydrogens, and B has got its 3 fluorines, and quite often you show it as an arrow, the bond as an arrow, to show that the pair of electrons has come from the nitrogen.